Hello. Today we will be talking about how to find the area of shapes. Now, first of all, there's like all the general formulas. A rectangle is just going to be base times height. A triangle going to be 1/2 base times height, and pretty much just all the other area formulas that we've already covered. Um, but this is just more about um, tricks, I guess. So first of all, similar figures. If you recall, a similar figure is basically if you take a shape and you copy and paste it, but then make it bigger or smaller, or you can even keep it the same size. So that just means for triangle, all the angles are the same, the ratio of the sides are the same. For square or like any sort of quadrilateral, the same thing basically. Uh, and similar figures, um, let's say that you have something like um, A, B, C, and then a similar triangle, and you know it's similar, which is KA, KB, and KC, where K is some constant. Now, the ratio between the areas is K squared. Now, why is that? Well, if you think about it, um, the area of a triangle is base times height, so the base is multiplied by K, and the height is also multiplied by K, which means at the end it's just the area of this initial triangle except multiplied by k twice. And then the same rule applies for squares as well, because really you're just multiplying the base and height by whatever constant k. So then the area will be, the ratio between the areas will be k squared. And the same is also true for circles, except based on like the radius instead, and also for hexagons, mostly because like the formula is used for it. Now, what if they're not similar? Um, but let's consider something else. Let's consider this triangle with base B, and this triangle also with base B, except they have different heights. So this is, let's say it's H, and let's say this is KH. Now, given what we've covered, that means the ratio between the areas would just be K. And yes, this might seem obvious, but then it, well, it could be useful sometimes. Like sometimes if you have a diagram like this and it's giving you the area of the triangle on the bottom and it asks you to find the area of, I don't know, say this segment, you can use this, the ratio between the areas to find the area of the larger triangle and subtract the area of the smaller triangle. And that's just one of the many ways that you might know for sure that two triangles share a base. And then the same also applies for height, of course. So if you have a triangle like this, well, you know they have the same height because the distance between the peak and the base is the same. But then their two bases are different. They're this base and this base. So, but even though the shapes are different, you still know the ratio between the bases is B1 and this B2. Uh, and this can also be useful to prove that two triangles have the same area. For example, if you just have two triangles that happen to share a height, and you also happen to know that their bases are the same, then you can prove that they have the same area. And also keep in mind that this can be used to determine the ratio of area between two rectangles, except this probably won't be useful as much because if you think about a rectangle, a rectangle basically looks like this anyways, so if we're just changing the height or the base, that's not really going to do much since it's just a lot easier to find the area of a rectangle. Now, final thing, trick I guess, is for a complicated figure. One simple example you might see in like grade 8 textbook or something is you have a basketball court and you have that looks like this, and then it's asking you to find the area of that. Well, what you would do is basically break it down like I have here. One rectangle and two semicircles, and then you just find the area of each and basically just add them together. And yeah, well, it might be simple. Sometimes it is the better idea just to break down shapes into smaller shapes. One example you might see in a math competition is with a hexagon like this. Well, although there is like the formula for the hexagon, sometimes it might be easier just to break it down into 6 equilateral triangles. Other times, you might just have to use this method. For example, if you have something like this shape here, where it's asking to find the area of this segment here, well, then you have to find, well, I guess this part of the circle isn't really that useful, but in any case, you can find the area of this entire semicircle and then subtract away the area of this triangle. And in this case, you would also recognize that this is halfway. And basically just break down the shape like that. So basically what I'm saying is you look at a complicated shape, sometimes just create a lot of triangles. So just some general strategies. First, draw radii to separate circles and circular segments. Second trick is look for equilateral triangles and also look for right triangles because those are really easy to find the areas of. And sometimes if you have interesting quadrilateral, sometimes even you can just split it in half into two triangles, which may not always seem useful at first, but then sometimes it allows you to put things into perspective and figure out a way to like compare bases. Like, for example, you can see that these two share a height, but then they have different bases, so you can just figure out the ratio between the area that way. So finally, I guess I'll just leave you with one practice problem. Okay, I'll give you a square. This is A, B, C, D. And this is a square, so all sides are equal. And now let's say we have this point E, this point H, this point F, and this point G. And I'll draw this. And let's say that actually, let's say that despite my bad drawing skills, let's say AE is equal to AF, which is equal to CG, which is equal to CH. So this, and this are supposed to be equal. I'm just bad at drawing it. And let's also say that AB equals 5. Now, given that the shaded region is 9/5 the area of ABCD, so this hexagon here, A, E, H, C, G, F, let's say that this portion of it is 5/9 of the entire area of the square. So then, given that, find AF. And I guess let's actually give you another problem to work with. This one's a bit more difficult. Okay, I'll give you a square with side 6. And there's one diagonal here. And let's give you 2 arcs. And let's say these arcs are part of a larger circle. And they have the center here at A and the center here at B. So basically both of these arcs are 1/4 of the entire circle. And given that like the side is 6, what is the area of this shaded portion here? Anyways, have fun with those 2 problems and see you next week.